The most important thing coming out of the key concept has to do with using the volume formula. Remember that the volume formula can be used to find the volume of any three-dimensional shape. But what we have to know is B, which is the area of the base. And the area of the base figure could be the area of a trapezoid, a triangle, a square, a rectangle, a pentagon, or any other two-dimensional shape. It might also be the area of a circle. Not in this lesson, but in future lessons. Anytime you know the area of the base, you simply multiply that by the height of the prism, and you can find that volume. Remember that the same is true also of a composite figure. So to find the volume of a composite figure, find the sum of the volumes of each of those pieces. So find the volume of each of those parts, and then use those volumes and add them together. Now let's take a look at question 5. This is a good critical thinking question. A cheese box is shaped like a right triangular prism. The box is 6 inches long by 4 inches tall and has a volume of 24 cubic inches. So what dimension are we missing in this problem so far? They've given us 2 dimensions of the prism, and they gave us a volume. So the volume is going to be the area of the base times the height. Do we know what the area of the base is? Well, that part is pretty easy because that's the triangle, which is 1/2 times 6 times 4. The other piece that they give us is the volume, which is 24. But what they don't give us here, let me try this, is they don't give us the height. So we're going to solve this equation to find the height of that prism in order to answer the question. And the question says, can a cube of cheese that is 2.5 inches on each side fit inside the box? So let's take a look at that. First of all, what is 1/2 times 6 times 4? That answer is 12. So what does the height of this prism have to be? Divide both sides by 12. And h must be equal to 24 divided by 12, which is 2. Since the height of this prism now we know is equal to 2, I'll put that in red there, then let's go back to the question. If I have a cube of cheese that is 2.5 inches on each side, would it fit inside this box? Okay, that's a good question. And the answer is nope, it won't fit. And why not? Because one of the dimensions of that cube is only 2 inches. So that means a cube that's 2.5 inches won't fit. In this next part, let's take a look at numbers 7 and 10. Number 7 is scaffolded, which means they give you an outline of the work that you are to do with finding the area of the base and multiplying by the height in order to find the volume of that triangular prism. See if you can complete number 7 and then come back and check your answer. Pause the video while you're working so that your answer will appear after you're finished. All right, did you pick out the correct numbers for the base and the height of the triangle? It's this piece right here. And then try to find the volume and see if you get the same answer I do. And the correct answer is 41 1600 meters cubed. Now let's move on to number 10. A volume of 185 and 5/10 cubic feet of concrete was used to make the section of a skateboard ramp shown. How long is the ramp? So I notice here on the picture that they put a question mark here along this side, meaning we don't know how long that ramp is. What we do know is we know the volume of the ramp, and we also know the dimensions of the base, and that's this piece here. So let's go ahead and work backwards to find the length of that ramp. Remember that the volume is equal to the area of the base, that's a capital B, times the height of that prism. In this case, the height is that question mark that we're looking to find. So this is the height that we're missing. The base shape of this prism is a triangle. So we are going to use, in this case, 1/2 times 4 times 7 in order to get the volume. But what we don't know, remember, is that height number. So we're going to replace, or we're just going to keep the h there, and we're going to replace the volume number, okay? But let's do the math here first. So 1/2 times 4 times 7 is 14h. Now remember, the volume is how much concrete they used to make that ramp, which was 185 and 5/10. So when I go to solve this, I need to still divide both sides by 14. There you go, so you can see that better. And the value of h, in this case the height, is how much? And that means the height of that ramp, or the length of that ramp in this case, is 13 and 25/100 feet, or 13 1/4 feet. Our last two problems will be numbers 16 and 17. Number 16. Ben uses clay to make the rectangular prism. Naomi uses cardboard to make the triangular prism. How do the volumes of the prisms compare? Explain. So the first thing that we need to do is we need to find the volume of Ben's prism, and then we need to find the volume of Naomi's prism. And then we need to make a comparison statement. So let's first look at Ben's. His prism is a rectangular prism, so the volume is equal to the base times the height. In this case, the volume is a base, 5 times 12, times the height of the prism, which is 2. That volume is equal to how much? If you said 120 centimeters cubed, you're correct. Now let's look at Naomi's. Her volume is also going to be a base times the height, but this time her volume, her base shape is a triangular shape, so we need to do a base, which is 5, times a height, which is 4. That base shape is going to be multiplied by the height of the prism, which is the distance between those triangles, this distance here, which is 12. So the volume of Naomi's is going to be the volume of the base, which in this case is 1/2 times 5 times 4, or 10 times 12, which is 120 centimeters. So what do we see about the volume of Ben's shape and the volume of Naomi's prism? Okay, these volumes are equal. Now let's do some problem solving with number 17. Freezer A has interior dimensions of 1 foot by 1 foot by 5 feet and sells for $499.99. Freezer B has interior dimensions of 1.5 feet by 1.5 feet by 4 feet and sells for $849.99. Which freezer is a better buy in terms of dollars per cubic foot? Explain. Well, first let's look at freezer A, and then we'll look at freezer B. So freezer A has interior dimensions. That means the inside. Okay, so interior means inside. 1 foot by 1 foot by 5 feet. So it's a rectangular prism, which means the volume is 1 times 1 times 5, or 5 cubic feet. The volume of freezer B is 1.5 times 1.5 times 4. So what is the volume of freezer B? Freezer B is 9 cubic feet. Now let's look at the prices. In order to find the dollars per cubic foot, we're going to take each of the freezers and their volumes and divide. So we're going to take the price of freezer A and divide it by 5 cubic feet to determine how much is that freezer for 1, that's a 1 cubic foot. Then I want you to do the same thing for freezer B, which was $849.99 for 9 cubic feet. And we want to know again that price for just 1 cubic foot. So find those numbers and then come back and check your answer, and we'll go over results. Take a look at the results. Is this what you expected to see? Freezer A is about $100 per cubic foot. Freezer B is only about $94 per cubic foot, which means freezer B is actually the cheaper option in terms of dollars per cubic foot. Now you're ready to move on and try some problems on your own.